Okay, this is going to be the second lesson in Unit 3 for pre-calculus. We're going to start with this kind of question. It says, write the equation in factor form where zeros occur at x equals -1, multiplicity of 2, x equals 6, and where p of 0 is 24. Okay, so here's how we do this. Okay, pretty simple. All right, if it's x equals -1, multiplicity of 2 as a factor, this is what it would be. At x equals 6, it would be x minus 6, okay? Now, it says find p of 0 when it's 24. So here's how we do that. If I put 0 in here and 0 in here, this would be 1 squared. This would be -6. 1 squared is 1, and this would be -6, which I get a result of -6, okay? Now, what I need is a result of 24. So how would that happen? I would have to have a times 4 in here, okay? Well, where would that occur? All right, how would I get a 4 there? It would be by putting a 0 plus 4, okay? So that's just going to be x plus 4. So this would be my function, okay? So let's have you try one. Let's say the zeros are at x equals 1 multiplicity of 3, x equals 7, and where p of 0 equals 56. So you go ahead and try this one on your own. Pause your video and then unpause. Okay? All right? So what I would do, x equals 1 would be x minus 1 cubed, because multiplicity of 3. That would be x minus 7, okay? To figure out this evaluation, I would put 0 in there, okay? And 0 in here, okay? So that'd be -7, okay? This would be 0 minus 1, which would be -1 cubed, which would make that -1 times -7 would be +7. Okay, how would I get that to be 56? It would have to be times 8. Okay, so how would I get that to be +8 if I got 0? All right, how would I get that to be 8? Be plus 8. So what this other factor would be x plus 8. Okay? Now, we're going to move on to something what they call synthetic division. Okay? The concept behind synthetic division, let me give you an example. Okay? Let's say 2x to the 4th plus minus 5x squared plus 5x minus 2 divided by x plus 2. Okay? So, here's how you handle this. Okay? The concept is, if you divide this, and just write this down, if you get no remainder, then what you divided by is a factor. Okay? Now, let's talk about synthetic division. The concept is x to the 4th. If that's your biggest one, x cubed, x squared, x and number. Okay? So what we're going to do is we're going to put the number that's in front of x to the 4th. Now x cubed, if you notice, there is none, so I'd put a 0. X squared, I put -5. X, I put 5. This, I put -1. Okay? I'm going to move this, put this little half box here. Now, what goes in the half box? The solution of that factor. Okay? That's going to go into the half box. So the solution for that would be -2. Okay? You got to convert between factors and solutions. Okay? So I do plus 0 all the time. All right? Always. Okay? 2 plus 0 would be 2. I take this number, multiply it up by here. 2 times -2 would be -4. 0 minus 4 is -4. Take this number. I'm going to multiply it by -2. I get 8. Okay? -5 plus 8 would be 3. I take this number, multiply in there, I get -6. 5 minus 6 would be -1. Take this number, multiply in there, I get 2. Result would be 0. Okay? All right? So what that means is a couple things. Is x plus 2 is a factor of this. We'll get into that in a second. Now, if I start at x to the fourth, this now is x cubed, x squared, x, and number. So my result there is 2x cubed minus 4x squared plus 3x minus 1. That would be my answer. The other thing is this x plus 2 is a factor. Okay, so that's two consequences of this. Okay, if you don't get a remainder, so what this number right here, that is going to be your remainder. Okay, in this case, we didn't have a remainder. Okay, all right, so, okay, let's say, let's do one, a different one. Okay, let's say I have 10x cubed. 10x cubed minus 13x squared plus 5x minus 14 divided by 2x minus 3. Okay? So, I got x cubed, x squared, x number. So 10, negative 13, 5, and negative 14. Put this little half box here. If I solve that, that'd be 2x equals 3, x equals 3 over 2. Okay? All right, put a 0. 10 plus 0 would be 10. Take that 10, multiply that. That would end up giving me 15. Add that would give me 2. Take that 2, multiply there, gives me 3. Add that, give me 8. Multiply there would give me 12. And then I got this as negative 2. Okay? So if it starts at x cubed, this is x squared, x number, remainder. Okay, so I'd write my answer as 10x squared plus 2x plus 8 minus 2. Now, what goes here is what you divided by. Okay, 2x minus 3. So we can say a couple things. That's the answer. And also, 2x minus 3, not a factor. Okay? And the reason why we know that is because basically we do not get a remainder. Okay? All right, so here's what I'd like you to do. I would like you to try these two questions. Okay? Let's do 6x to the fourth plus 11x cubed minus 15x squared minus 12x plus 7 divided by 3x plus 1. And then I'd also like you to do 4x to the fourth plus 21x cubed plus 25x squared minus 5x plus 3 divided by x plus 3. Okay? So go ahead and pause your video and go ahead and work on those. All right, unpause. All right, so I got x to the fourth, x cubed, x squared, x number. All right, so that's 6, 11, negative 15, negative 12, and 7. Big line with a plus 0. If I solve that, I would get negative 1 over 3. 6 plus 0 is 6. Multiply in there gives me negative 2. That would give me 9. 9 times this would give me negative 3. That'd give me negative 18. Take this, multiply, I get 6. That'd give me negative 6. Multiply that would give me positive 2. And then that would give me 9. Okay? All right, so what do I have? This is x to the fourth, x cubed, x squared, x number, remainder. Okay, so I got 6x cubed plus 9x squared minus 18x minus 6 plus 9 over, what did I divide by? 3x plus 1. Okay, we also know that 3x plus 1 is not a factor. Okay, this one, same concept. I'd have 4, 21, 25, negative 5, and 3. Half box. If I solve that, that'd be negative 3. Okay, so that'd be 4 times that would be minus 12. That would be 9. Take that, multiply there, give me negative 27. Gives me negative 2. Multiply that, gives me 6. Gives me 1. Multiply that, gives me negative 3, which gives me 0. Okay, so if this is x to the fourth, this is x cubed, x squared, x number. So 4x cubed plus 9x squared minus 2x plus 1 is my answer. We also know that x plus 3 would be a factor of those. Okay? Now, how do we apply this concept? Okay? All right? Let's start with find the factors of, let's say, the function x to the fourth minus 2x cubed minus 27x plus 54, where x equals 2 is a solution. Okay? So we got to find the factors here. All right? Now, what we know is, okay, if that is a solution, okay, then the factor for it would be x minus 2, so that helps me. Okay? Now, I'd have x to the fourth, x cubed, x squared, x number. Okay, so that's going to be 1, negative 2. Now, my x squared term, you notice I don't have one, so I put 0. My x term is negative 27, and this would be 54. Okay? All right, 2 is going to go in here. 1 plus 0 would be 1. 1 times 2 would be 2. Gives me 0. 0 times that would be 0. 0. 0 times that would be 0. That's negative 27 times that, negative 54. So this would be x cubed, x squared, x number, and I should have no remainder. So what this is x cubed minus 27. Okay? Now, should have learned how in Algebra 2, okay, how to basically factor things like this. Okay? So for a cube, there is a pattern. Okay? This will be, all right, take the cube root of each term. Okay? All right? These two terms are logical. X times this has got to give me that, which would be x squared. This times this has to give me that, which would be 9. Okay? To get the middle term, multiply these two, x times negative that, and then when you move it over here, go ahead and change the sign. So positive 3x. So it's a little bit of a pattern. Okay? So my factors are this, this, and my original one of x minus 2. Okay? All right? Let's have you guys do one. Okay? Find the factors of, here's your function, 27x to the fourth plus 135x cubed plus 8x plus 40. Okay? All right? Where x equals 5 is the solution. Okay? So go ahead and pause your video and see if you can work through that one. Okay? Go ahead and unpause. So what I got here, I'd put 5. That's x to the fourth, x cubed, x squared, x number. So it'd be 27, 135, 8. Okay? Whoops, I'm sorry, not 8. This would be 0, 8, and 40. We're negative 5, sorry. Okay? So I've got 0, 27. 27 times that is minus 135. That would be 0. 0 times that would be 0. Add that would be 0. 0 times that would be 0. That'd be 8. Times that would be negative 40. Okay? So my result here, this is x cubed, x squared, x number. Okay, so I got 27x cubed plus 8. Okay? All right, so if I factor that, cube root of each of these terms, cube root of this would be 3x, cube root of this would be 2. Okay? These next two are logical. These last two. This times this has got to give me that. That'd have to be 9x squared. 2 times this has got to give me that, which would be 4. To figure out the middle ones, let's multiply those. That'd be 6x. And when I move it over here, I change the sign. Can't forget about my original factor of x plus 5. So that would be those factored. Okay? All right, moving on to the next thing here. Let's say it says find all factors and solutions of, okay, let's say x cubed, f of x is x cubed minus 7x squared minus 18x plus 40, where x minus 4 is a factor. Okay? All right, so I can go ahead and use synthetic division. All right, that's going to be x cubed, x squared, x in number. Okay, so this would be 1, negative 7, negative 18, and 40. Since this is a factor, I know the solution of that would have to be 0. Okay, that would be 1. 1 times that would be 4. That's negative 3. Negative 3 times 4 would be negative 12. Okay. Something's not right here. Hold on one second. Let's go ahead and change that. Sorry. And the reason why I knew I was wrong, let's change this to plus 2. So, yep, and that would be negative 10. That'd be negative 40. That'd give me 0. Okay, sorry about that. All right, so then what I have here, this is x cubed, this is x squared, x in number. Okay. So I got x squared minus 3x minus 10. Okay? Now, this is something very simple to factor. This would be x minus 5 times x plus 2. Okay? So I've got these two factors. My other factor is x minus 4. My solutions out of that would be 5, negative 2, and 4. Okay? 3 solutions. All right? 3 factors. Okay? All right? Next question, find all factors and solutions of f of x equals 2x cubed minus 13x squared plus 3x plus 10, where, let's say, where 2x minus 3 is a factor. Okay? So, what I would do, I got my synthetic division, 2, negative 13, 3, and 10. All right, what's going to go in here would be 3 over 2. Okay? 2 plus that is that, multiplied times that would be 3. That'd give me negative 10. Take that, multiply in there, would give me negative 15. Okay, which would give me negative 12. Times 2 would be 3, negative 10. Yeah. Hold on one second, sorry. Wrote this down. X squared. 2x squared minus 3 minus x cubed minus x squared minus 3x minus 12x squared, which would be minus 13, plus 6x, which would be 3. And this should be 18, sorry. Okay? Negative 12 times that would give me negative 18. let's change our factor here. Let's change the factor to x minus 6. Okay, let's see if this works out a little bit better. That'd be 6, 2, negative 13, 3, and positive 18. Okay? Would be 2, 2 times 6 would be 12, that'd be negative 1. Negative 1 times that would be negative 6. Negative 3, negative 18, 0. Okay? So what I would have here is 2x squared minus x minus 3. If I would factor that, okay, that would be plus 1 minus 3. Okay? So my other factor that joins it would be x minus 6. The solutions out of there would be 3 halves, negative 1, and 6. Okay? Sorry about that. Switched up the wrong factor on that. Okay? Moving on to the last thing for today. Okay? All right. Let's say given the function, draw the graph. Okay? So let's say the function is negative x plus 2 squared, x minus 3 cubed, x minus 5. Okay? Now, what you have to look at is a combination of the zeros and the multiplicity. Okay? So my zeros are x equals negative 2, x equals 3, x equals 5. Okay? That's the first thing. We'll talk about the multiplicity. Now, since what you want to do also is look at the exponent. Okay? So the exponent here, I got 3, 2, and this is an exponent of 1. So I should have a degree of 6. Okay, I also want to look if it's positive or negative. In this case, it is negative. All right? So, if it's an even degree, okay, all right, what I would do here is at negative 2, I'm going to put a dot. At 3, I put a dot. And at 5, I put a dot. Okay? Now, since it is even negative, that means that at my last zeros, I should have arrows both going down, and that's what we've talked about with end behaviors. Okay, now, as I go through this negative 2, since it's squared, it should be a quick touch. Okay? Now, when I come through this, through 3, since it's a cubed, it should curve through. Okay? And then when I get to this one, it should slash through. Okay? All right? Now, boom. That would be my answer. Okay? All right? That could be one of the drawings. If you wanted to be accurate with the turns, okay, I could, because I only got 1, 2, 3 turns. I should have 5. I could always, if I wanted to, okay, put an extra 2 turns, just like that. So now I got 1, 2, 3, 4, 5 turns. Okay? The big thing here is you want to count the exponent. You want to look at whether it's positive or negative. We want to use the zeros, and we want to use the multiplicity. Okay? Let's have you guys try one. Let's say the function is x plus 5 cubed, x minus 1 squared, x minus 4 squared. Okay? So we'll have you guys try this one. Okay? So go ahead and pause your video, and then you can work on this. Okay? All right, so I've got zeros at negative 5, zeros at 1, zeros at 4. Okay? Some people would just like to go ahead, 1, 2, 3, 4, 5, put a dot. At 1, put a dot. At 4, put a dot. Okay? Now I got 3, 5, 7. So I got a 7, which would be an odd function, and it's positive. So the arrow's got to go like this. So the last arrow has to have an arrow this way, and this last 0 would have to have an arrow that way. Okay? So as I draw this, I would curve it through that. Okay? Then when I get to this one, I would quick touch. And then getting to this one, I got a quick touch, and then I got to go. Okay? All right? So for me, that would be good. All right? As far as your polynomial, okay, if you wanted to get the exact number of turns, you could obviously put an extra curve in there. So that was a little bit long video. Sorry about a couple of those mistakes. All right, just try to power through those and you'll be fine.